whether my screen is visible or not.
Yeah, voice is clear.
Fine. Okay, fine. Thank you. Thanks for the confirmation. And fine. So in the last class, just I was demonstrating about what is Hadoop, what is big data, what is Hadoop, the drawbacks of databases, why Hadoop. Okay, yeah, 1 second.
Today is my first class, sir.
Yeah. Yeah, I was saying like day by day, huge data is getting generated. So we need to have proper storage systems to store the data and to process the data. So as a solution to all this, we have got a framework called Big Data Hadoop for storing huge data and for processing this huge data. So for that, we have got a framework called Hadoop. Hadoop is meant for two things. Yes, I want the sessions to be interactive. So keep responding either through voice or through chat panel. Okay, fine. Hadoop providing two services. What are the two services Hadoop is providing? Generally, if you see any technology, it just performs either storage or processing. So, but Hadoop combines both. It performs both storage and processing. Hadoop performs both storage and processing. Fine. This is for storing data and for processing the data. It is for huge storage, huge data storage, and for huge data processing. We use this Hadoop. Fine. So for storing this data, Hadoop doesn't use any database internally because databases has got drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases for storing its data. Rather, it is going with a special kind of file system called as Hadoop distributed file system. And for processing the data, Hadoop going with an execution model called as MapReduce and also going with SPARK. MapReduce or SPARK. So Hadoop meant for two things: storage and processing, huge data storage and huge data processing. Unlimited data storage and unlimited data processing, and processing the data in a very quick time. Not in GBs, processing the data in terabytes, petabytes, exabytes of data. So I was saying like Hadoop not meant for OLTP. It is not for OLTP, online processing. Difference between there are two types of processing we can say. So just to be clear with this. So there are two types of processing: online processing, and batch processing. Difference between online processing and batch processing. Online processing or OLTP, online transactional processing we say. So what is that online processing means? User interference required. So what is that? Online applications or batch applications? Online processing means user interference required. Here, user interference not required. So here in batch processing, Hadoop is meant for batch processing. You need to understand this. Hadoop is meant for batch processing. For a single record level operations, we won't go for Hadoop. For record level operations, no need to go for Hadoop. For one record, two records, no need to go for Hadoop. Once again, I'm saying this. Why we go for Hadoop or Spark environment, like batch processing, billions and trillions of records. But for record level, for online single record, for example, I made an online transaction. So for that, Hadoop is not required for a single transaction. For millions and trillions of transactions. So what is the main difference between online and batch? User interface. Example of online processing. For example, you are booking a ticket, movie ticket, booking a movie ticket. It's a online processing. Paying electricity bill, through online processing. You are just what you do, like amount to transfer. You're making a transaction. Yeah, transferring amount. So it's a online processing. Example of batch processing. Yeah, ordering an item from the Amazon. Yes, you're just making a transaction with Amazon or Flipkart. You are making a transaction with Paytm, or booking a movie ticket, book my show, anything. It's all these are online processing. You are making a single transaction. Okay, fine. This online OLTP. But if I want example of batch processing, any example of batch processing? So railway ticketing PNR status. For example, today your waiting state is like 150. Tonight it became like 100. Tomorrow morning it became 30. Tomorrow evening your ticket got confirmed. Means here, observe whether the user interference required here. For booking a ticket required. You are making a transaction with, you are just transferring some amount to your friend. You need to enter your details, account details, all the things. So for online processing, user interference required. But here PNR status, you were nowhere required. Other examples. So which one has got a more load? Which has got more load, batch or online? Try to answer. Which has got more load, batch processing or online processing? Which has got more load?
Batch
Yeah,
processing.
yeah, batch processing has got more load, right? So for example, so most of these financial applications, the batch processing. For example, generating credit card bills for all the customers, batch processing, right? Generating credit card bills for all that customers, lakhs, millions and trillions of customers. Or for example, bank statement or telephone bill generation for all that millions and trillions of customers, right? It's the batch processing. Millions and trillions of customers generating, what is that? Mobile bill generation or credit card bill generations. All this comes as batch processing. But if you're making a single transaction, it's an online processing. Fine. So Hadoop is meant for batch processing. It's not for online transactional processing. But if Hadoop wants to perform online processing, so even in we are going to integrate Hadoop with NoSQL databases. Hadoop and NoSQL data, where Hadoop performs batch, NoSQL performs online processing. Combine it together, they can perform both batch and online processing. Even NoSQL databases has got a great boom in today's market. NoSQL, not only SQL, schemaless behavior. We are going to discuss NoSQL database also in our course. Fine. So why Hadoop doesn't use any databases? Why Hadoop doesn't use any database for storing its data? Why Hadoop doesn't use any database? Because we have got some drawbacks with the databases. Limited storage. What is that? Limited storage in GBs or TBs. And yeah, most of the databases, no parallel processing you are going to see. No parallel processing. And if you observe, As volume increases, speed, if the volume increases, speed decreases. Fine. If the data is in databases, if volume is increasing, speed is decreasing. I'm giving an example like if you want to find the total sum of amount of 1,000 records,
Is
the sum
also
of
an example.
1 lakh records or 1 crore records. So observe here, if the volume increasing, speed decreasing. Next, complexity increases, speed decreases. Speed, for example, I am writing a SQL query, sum of amount from sales consisting of 1 lakh records. Sum of amount, next one more query, average amount, next one more standard deviation of amount. Some query to query, see here, average amount takes more time as sum of amount, and standard deviation, lot of internal processing required. So query to query, as the complexity increasing, speed decreasing. And majorly databases can handle only structured data, so can handle only structured data. They cannot handle unstructured, or can handle only data only. Okay, they cannot handle unstructured or semi-structured kind of data. So this is what drawbacks of databases. Despite of this drawbacks, still Hadoop doesn't use any databases for storing its data. Hadoop advantages. Let me discuss about Hadoop advantages. Observe this. First one, unlimited data storage. Unlimited data storage is possible in the case of Hadoop. Second is very high speed processing you are going to see in Hadoop. Very high speed processing because because of parallel processing. Very high speed processing because of parallel processing. And can handle all varieties of data, structured, semi-structured, unstructured data. Can handle all varieties of data. Next, open source. Hadoop is an open source, no licensing required. Is it an advantage? Can you say open source, no licensing required? For example, if you want to establish a company, a small company with 10 crore rupees, 10 crores means, for assume that 4 crores, 6 crores. 4 crores you require, if you to establish a company, you require like hardware and software, right? One second. A company with 10 crore rupees, which requires hardware and software resources. Yes. If you're spending 4 crores for this hardware, you are spending 6 crores for software. Means each and every software need to be licensed, right? Starting from Office, Windows, everything. So here Hadoop is an open source, no licensing required, means cost cutting, right? So it's open source, no licensing required. And commodity hardware we say, means no need of high configured systems. So here with the normal configured systems, and just unlimited data storage, very high speed processing, can handle all varieties, and open source commodity hardware. Fine. Observe these things carefully. Yes, I was just briefing you about that. Just Hadoop follows master and slave architecture. It won't follow client server architecture. Single master, multiple slave architecture. Single master and multiple slaves. Observe. S1, S2, so on, Sn. This is a master, we call master node. Okay, these are called slave nodes. In Hadoop terminology, like we call them as name node. This as like data nodes. Data nodes. Observe these things. So this entire thing we call it as a cluster. What is this? A cluster. This end we call this as a cluster. This is we call it as group of. What do you mean by cluster? Group of CPUs, nodes, CPUs. CPU is nothing but here we call it as nodes. Group of CPUs nodes connected in a network. Connected in a network. We call it as a cluster. Observe this thing. Cluster is nothing but group of CPUs nodes connected in a network. Two types of nodes here. Two types of nodes. Master node, slave node. Name node, data node. You need to say as name node or data node. Observe, just yesterday I was saying like how why only Hadoop is able to store huge data, why not the other databases, why not about the other databases. Now see, for example, in Hadoop data is stored in the form of files. In Hadoop, in database data is stored in the form of tables, right? But in Hadoop data is stored in the form of files. f1.txt file. Think that it has got some 5 TB. The file size is of 5 TB. Okay, think that each slave size is of 1 TB, 1 TB, 1 TB, 1 TB capacity, storage capacity. So this like hundreds of slave systems are 50, hundreds of slave systems are available. So here this 5 TB file cannot fit into any slave. For example, if it gets fit, then only that system, that slave need to store the data. That slave only need to process the data. For example, you have got some work. Think that, let me give a labor example. You have got a work. Think that your a house construction work, which requires 20 to 30 labors. But if you assign only a single labor for that house construction, it takes months and years of time, right? But instead if you are keeping 20 or 30 labors parallelly, they are going to execute and complete in a very in the same way. This 5 TB of work, if you are just assigning to a single system or slave, so same that slave, the same system need to store and it need to process the data. But here two things you need to observe here. Hadoop advantages you can see. The data, 5 TB of data, it is not going to store on a single system. Distributed Hadoop distributed file system. I was saying like HDFS. Hadoop follows what? HDFS here. Hadoop distributed file system. Okay. Now this 5 TB of data is going to get splitted into smaller parts, smaller chunks, fixed size chunks. We call them as blocks. So this later I'll demonstrate how what exactly happens internally and how the data is getting stored, how data is getting processed. But observe that 5 TB data is divided into smaller part. Each part is stored across one system. Each part across one system. Each part is stored across this system. Means data is getting distributed across the multiple slaves or multiple systems. Think that 10 lakh records in this, 10 lakh records in this, 10 lakh records in this. So data is getting distributed across. 10 lakh records processed by this S1, 10 lakhs record processed by S2, 10 lakh records by S3, S4, S5. Means multiple systems. Means think that you have got some 30 slaves storing the data of a single file and processing it parallelly. So you are going to achieve more speed, right? High speed. So data is getting distributed and data is getting processed by multiple slaves. Fine. Yeah, can one query asked by Nitish Chaudhary? Yes. Can two blocks be stored in a single node? Yes, possible. Okay. For example, think that I got only 1 TB of data. I got only 4 slaves. Assume 4 slaves. So that how many blocks are there? Think that it was divided into some 20 blocks. 5 blocks in this, 5 blocks in this, 5 blocks in this, 5 blocks in this. Very simple to say, but I got some, for example, house construction work. 20 tasks are there. Available labors, 4 labors. Each labor need to be assigned with 5 tasks. First labor 5 tasks, second labor you are going to assign 5 tasks, third labor 5 tasks, 5 tasks. Means what happens here? All the 20 tasks, will they get executed parallelly? Is it possible? I want a response from your side. I want the sessions to be interactive. Please try to respond. So here all the 20 tasks, will they be getting executed parallelly simultaneously? Not possible, right? 20 tasks executing parallel. Only maximum 4 tasks can run parallelly. 4 labors can execute only 4 tasks. See here, think that for 20 tasks, each task it takes 1 hour. For executing 20 tasks, 20 hours it takes. But if I keep 20 labors, it completes in 1 hour parallelly. But there are only 4 labors. The first labor takes 5 hours, second labor 5 hours. So maximum 5 hours it takes to complete all these tasks if I keep 4. But if I keep 20 labors, within a single hour it gets completed, right? If I keep 40 labors within half an hour, just if I increase that further more, just in 15 minutes it gets complete. Understanding? So if more number of slaves, the works gets completed faster. So here 20 tasks, 20 slaves means full parallelism. All the tasks are executed parallelly. But here, if only 4 labors are there, means 4 tasks only will be running. Remaining 16 tasks will be in the waiting state. 16 tasks are going to be in the waiting state. First round finished, everyone completed 1 task. Second round again, third round, fourth round, 5 rounds they need to do. Fine. So here also the same thing. You can store that blocks, but here what happens? If less number of slaves or less number of systems, in that case you can store that. But here some S1 need, for example, 5 blocks are stored by S1. Then 5 tasks need to be executed by system 1. 5 tasks means one after the other. So that's what. Okay. Yes. So the data is getting distributed is one, and data is getting processed by multiple slaves parallelly. Both the things. Okay. Here I need to say executing this 10 lakh records is nothing but a task 1. 10 lakh, this 10 lakh records is task 2, task 3. So multiple tasks are executed by multiple slaves parallelly. Okay. So here I need to discuss what are the master node responsibilities and slave node responsibilities. Master node responsibilities. So for example, you may ask one query here. You may ask one query. Yes, observe. If data stored, see here, I'm saying this as data nodes, slave nodes. If why we are calling them as slaves or data nodes means everything done by them. Data stored by the slaves, data processed by the slaves. Here data getting storage, data getting stored within the slaves, data getting processed by the slaves. Both done. Everything done by the slaves. Storage in the slaves and processing. Then what the master node does? Data stored in the slaves, data processed by the node. Yes, exactly. Yes, it gives the order. Yeah, I got some queries like this. So yeah, now sir, let me say master node responsibilities. So once again, yes, Nitish Chaudhary, yes, it keeps the information about the nodes, about the tasks, about the jobs, everything. It maintains the track of all the jobs, which job, which task is given to which slaves, all those. Let me discuss that. So once again, I draw it neatly for the better understanding. Assume this master, these are slaves. S1, S2, S3, S4, this master. Data nodes, f1.txt file divided into smaller parts. Think that of 4 TB size divided into smaller parts. Each part stored across this slave. Each part stored across this slave. Okay, now assume 10 lakh records. I said 10 lakh records, 10 lakh records, 10 lakh records. Here, this is T1 task. This is executing this 10 lakh records is T2. This 10 lakh records by S3 in this way, T4, T1, T2, T3, T4. Now see, master node responsibilities. Task assignment. Who is going to assign tasks to the slaves? So here, master node, right? Master node or this name node assigns the task to the slave nodes. T1 task assigned to S1, T2 to S2, T3 to S3, T4. Means what is T1? Executing this first 10 lakh records. T2 next 10 lakh, 10 lakh records. Task assignment. Next, load balancing. For example, load balancing. For example, all this, assume S1, S2 are executing tasks. S3 and S4 are free. S1 and S2 are executing some tasks. S3 and S4 are free. A new task comes. To whom to assign? S3 and S4, which are free, right? I cannot burden S1 and S2. So this load balancing, if any new job comes, divide the job into tasks. Those tasks again are going to distribute across the slaves. Again, this load balancing. Observe this fault tolerance. This is important. Fault tolerance. Fault tolerance means, observe carefully. If four tasks T1, T2, T3, T4, four tasks are executed by the four slaves parallelly. Assume that 30 tasks are there. 30 tasks are executed by 30 slaves parallelly as they are systems, machines. Suddenly, if any system goes down, then the task of that particular slave need to be allocated to any of the available slave. That work is done by the master node. This process we call it as fault tolerance. If multiple tasks are executed by multiple slaves parallelly as they are machines, if any system goes down, then the task of that system need to be allocated to any of the available system. Who takes care of this? Master node. This process we call it as fault tolerance. For example, S1, S2, S3 are executing three tasks parallelly. Suddenly, if S2 is down, S4 is free, right? We can assign the same task to S4. For example, four laborers performing four tasks. Suddenly, one labor not feeling well. Then we will just assign the task to any of the available. Otherwise, think that only three laborers are available, only three slaves are available, three systems. S1, S2, S3 are only available. Suddenly, if S2 is down, in that case, I doesn't have any slave systems more. Only three systems executing three tasks. Suddenly, one system is down. Then any one of S1 or S3 need to perform two tasks, right? So that T2 task will be assigned. This T2 task will be assigned to either S1 or S3. Means any one slave need to perform two tasks. Fine. Okay, that is fault tolerance. Health monitoring. Health monitoring. So name node will have, so this master node will have, yes, good question. Yes, by Nitish. Okay, I'll come back to that query, but before that, health monitoring. Before assigning tasks to the slave, so first the master node will have that entire details of about each and every slave. Even not only that, master node can be able to predict if I assign a task to a particular slave, what is the time taken. For example, I can say like this: three students. I got three students are there: S1, S2, and S3. For example, I gave training for these students. Based on that, for 3 months I have given training. So based on that, within the 3 months, so based on the responses, I'm saying that S1, if I give a task to S1, he will just take just 1 hour time to do the task. If I give the task to S2, I can predict that if I give the task to a student 1, he takes 1 hour. If I give the task to student 2, it takes 4 hours. If I give the task to the same task to S3, it takes like 7 hours. So what is my first preference? To whom I need to give the task if any task comes? S1, right? Which is completed, which completes in 1 hour. But think S1 is busy. The student 1 is busy, as already I have given many other tasks. Then I am giving the task to S2 or S3. The same way here, the master node can predict if I give any task to the slaves, what will be the, yeah, S1, S2, S3, S4. Okay, now observe. Assigning tasks to the slaves, master node responsibilities, task assignment, load balancing, fault tolerance mechanism. If any slave goes down, again I am going to reallocate the same task to any of the available slaves. Health monitoring, and any, if you observe here, T1, T2, T3, T4, my job divided into tasks. T1, T2, T3, T4. Who does this? Master node divides a job into tasks and assign the task to multiple slaves. Fine. Task assignment, that is what. Load balancing. Fault on if any task, this one by S1, this is by S2, this is by S3, this is by S4. 4 tasks assigned to 4 systems. Suddenly, during the processing, if this is down, then this T2 task need to be assigned to any of the available slaves. That is what fault tolerance. Fine. So more brief about these things I'll be discussing in the architecture, Hadoop architecture. Just this is what overview what I'm giving as of now, to know that advantages. So but later will be discussing Hadoop architecture, storage architecture, processing architecture. In the storage architectural components, processing architectural components, I'll be giving more brief about each and every responsibility, and I'll say what happens internally, what is going to happen. Okay, what exactly happens. Fine. So just to say this, master, and can you please say slave node responsibility? Slave node responsibilities. Two responsibilities I can say. Storing data is one, processing data. Storing data and processing data. Okay. Hadoop advantages, unlimited data storage is there. I got some query here. Why Hadoop can only perform this unlimited data storage? Why not the other databases? Observe this. I got a query like this. Why database like Oracle? Why Oracle doesn't support unlimited storage? Why Oracle doesn't support unlimited storage? So if you observe even in the real time, like if you see database like Oracle, we can go with multiple slaves. If you have see this databases, if we observe this databases and see max limit, observe this max limit on number of slaves. Observe this max limit on number of slaves. Okay, databases like first, if I take Oracle database, observe this Oracle database maximum it can go with 256 slaves. 256 slaves or nodes. Slaves means what? Nodes, CPUs. Once the 256 slaves gets filled, it cannot store data further. It cannot. Maximum Oracle supports 256 slaves max. Just like if I give a labor example, you got a mobile phone. In that you have got some internal storage. You have got some storage like 64 GB. So okay, but once the 64 as they have given 64 GB, if you are filling all the 64 GB got filled, then the performance of the phone gets degraded, right? In the same way, if all the 256 slaves gets filled, the performance of Oracle also gets degraded, even it won't be started sometimes. If I go with other databases like MySQL, can go with max of 54 slaves. MySQL Express is there. MySQL Express edition, 256 slaves. DB2 SQL Server. SQL Server also it can go with 256 slaves. And as a DB2 256 slaves. So all these databases are used for what? OLTP, online transactional processing. But none of these databases are supporting unlimited data storage, max 256. Once the 256 gets filled, they cannot store data further. But we have got some specialized databases like Teradata. It can go with 512 slaves, 512 node CPUs for storing its data. And we have got some other specialized databases like Netija, specialized databases used for data warehouse purpose, like we have got 512 slaves. And Vertica, they can go with 512 slaves, 512 CPUs nodes. But if you discuss like Teradata and Netija, currently both they are going with 1024 slaves they are supporting. 1024 slaves or CPUs are supported for this Teradata and Netija. I'm sorry, 1024 slaves or CPUs or nodes supported for storing its data. But still 1024 slaves or nodes, if you are saying it's not unlimited storage. Once the 1024 gets filled, it cannot store data further, right? Even though 1024, I'm not saying like unlimited data storage is not possible here, but there is no limitation. There is no limitation for Hadoop. Hadoop, if you observe here, just before I was saying like advantage. Once again, can anyone please confirm whether my voice is clear or not?
Correct.
Yes, your voice is audible.
Yes. Yes. Okay. Then Hari, you need to check on from your side if there is any problem. Fine. So just now I was saying like the advantage. See, you can just check it here. Unlimited data storage in Hadoop is possible, because of there is a feature called horizontally unlimited scalability. Horizontally unlimited scalability. Horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Observe that in Hadoop. So here, see this. Think that you have got 4 slaves or 5 slaves. Think that your business has increased, customers are increased, branches are increased, data gets increased, right? So even you need to increase the number of slaves. Means horizontally you can keep on adding, scaling. Horizontally unlimited scalability. Horizontally unlimited number of slaves can be added for Hadoop. Commissioning and decommissioning, we say adding and removing slaves. Okay. So here I was saying like databases or specialized databases, they can store up to some extent, but for Hadoop, there is no limitation on the number of slaves. For Hadoop, there is no limitation on number of slaves. You can go with unlimited number of slaves are allowed for Hadoop, not 256 or not 512 or 1024, like unlimited number of slaves. For okay, Hadoop is proven in the market. Hadoop, if any technology comes in the market, lot of tests will be made on that. Okay. Okay. For example, even for Hadoop also lot of tests were made, storage point of view, processing point of view as compared with other technologies. So storage point of view it was done, processing point of view also lot of tests were done. So Hadoop was proven in the market and was successful. Observe this. Storage point of view, if I say Hadoop, when Yahoo first time implemented Hadoop, assume, see, it was done when Yahoo first time implemented Hadoop. It used nearly 4,000 slaves for storing its data. 4,000 slaves for storing its data. When Yahoo first time implemented Hadoop, it used nearly 4,000 slaves. Currently Yahoo using 12,000 slaves for storing its data. 12,000 slaves for storing its data. When Facebook first time implemented Hadoop, it used nearly 8,000 slaves for storing its data. 8,000 CPUs or 8,000 nodes slaves for storing its data. Now, currently, Facebook using nearly 42,000 slaves for storing its data. 42,000 slaves for storing its data. Okay, so that is what if we compare with the other databases like Oracle, MySQL, Teradata, where they can go with hundreds and thousands, but here for Hadoop there is no limit on the number of slaves. We can go with thousands, 4,000, 10,000, 40,000. So Hadoop is proven in the market storage point of view. And if I come back to this store processing point of view, I was giving an example in the session. Very high speed processing you are going to see because of parallel processing. Because of this parallel processing, if data is getting distributed, then if you are distributing the data, then only parallel processing is possible, right? For example, I was saying a labor example. If you are distributing the work to different labels, then only parallel processing possible. Here also, if the data is getting distributed, then only parallel processing is possible. So here very high speed processing because of parallel processing. Okay, 1 second. So processing point of view also Hadoop has proven in the market. Observe this processing point of view. Yesterday I was saying the same. So once again, Yahoo has conducted a test to check the speed of various databases in the market. So it has taken a table outside 100 TB consisting of 1024 columns. So 100 TBs of data. Okay, the task is sorting based on 16 columns. Sorting based on 16 columns. So what is the time taken by the various databases? The various database. I was saying like Oracle has taken, you can see this in the websites also, like the speed as compared with various other databases. Oracle has taken nearly 3.5 days to process this 100 TBs of data, and MySQL has taken nearly 6 days to process this data. But Teradata specialized database, it has just taken 4.5 hours to process it. And Netija, it has just taken 3 hours, okay, to process it. Finally, if see Hadoop has just taken 3.4 minutes to process this data. That is what the speed of Hadoop. It was proven in the market. Latest version has just taken 1.2 minutes. 1.2 minutes. Okay. So where you see this minutes of time, but see the other databases days and hours. So that is what Hadoop is proven in the market, storage and processing point of view. Hadoop was introduced in the year 2005, and that development, many POCs were done and many applications got developed since from 2011 onwards. If you see, lot of applications and Hadoop using Hadoop and Spark. Spark came into the market. Spark was introduced in the year 2009, and it was became open source in the year 2010. It was donated to Apache in 2012, and applications where POCs were done on Spark from 2015 onwards. So here both Hadoop and Spark, later I discuss about Spark also, very high speed processing for Spark. So this is what Hadoop is proven in the market, storage point of view and processing point of view. So motivation towards Hadoop and Spark, because this unlimited data storage and high speed processing. And apart from this, what are the other advantages? I was just briefing you. Unlimited data, very high speed, can handle all varieties of data, structured data, unstructured data, and even semi-structured data. What Hadoop can process all this. Open source, no licensing, and commodity hardware. Fine. I was just briefing you the drawbacks of databases. Why Hadoop not taking this databases for storing its data, and why it is going with Hadoop distributed file system. Data is getting distributed, and for processing, Hadoop using MapReduce execution model for processing this data. Right? Okay. Now, once again, let me show you 1 second. So Hadoop, Spark and Scala. Hadoop and Spark, right? But now Spark is much more faster. Spark is 100 times faster. Hadoop is, I'm saying Hadoop is very much faster as compared to the, but Spark is 100 times faster than Hadoop. That's why currently for storage purpose, like HDFS, we are going for Hadoop distributed file system, and for processing, we are choosing Spark. So implemented by using Scala is a language. Scala is a language. So Scala is a hybrid language where it has got, I can say it is, Scala is an hybrid language where it has got multiple features. So in our course we'll be discussing about, I will be just giving knowledge on this, not knowledge. In brief, I'll be discussing about Scala language, and next I'll go with Spark. Spark is an execution model implemented by using Scala language and Hadoop. See, first, how to bring from where data is coming, from where you are going to pull the data from different sources. Even I'll give knowledge on this streaming technologies. Even in real time we use streaming technologies also. Streaming data also. You need to have knowledge on the streaming data. What do you mean by streaming the data? Anyone? I'm going to give like streaming data, that streaming data and technologies, give you the knowledge on the streaming data like Flume and Kafka we use for that. And streaming data means a very small example. For, for example, streaming data means what is static data and streaming data? Streaming data. For example, you have taken a file. For example, f1.mp4 file, mp4, a movie, you have downloaded a movie of 2 GB, a 2 GB file you have downloaded. Morning, if you see the size, it will be like 2 GB, right? Evening, you see, it will be like 2 GB, right? After 2 days also, if you see, it will be like 2 GB, right? Static, the size won't increase. Streaming data means, for example, if you have f2 is a file. For example, if you take example of a webcam or CCTV, so you got some data. So morning, if you see, the size is like 2 GB. Evening, it becomes like 4 GB. 4 GB. After 2 days, it becomes like 10 GB. After 1 week, it becomes like 30 GB, right? Means here data keeps on incrementing. Data keeps on incrementing. Data keeps on generating. Data keeps on generating. Data keeps on incrementing. Such kind of data we call it as streaming data. The data which keeps on generating, the data which keeps on incrementing, such kind of data we call it as streaming data. So this data also we have got some tools. Even we need, I'll just give the knowledge on that streaming data and technologies like Flume and Kafka. So we are how to capture that kind of data, and also how to store the data in Hadoop environment, and later processing the data, right? Okay, so this is what introduction to this data is, big data Hadoop. And just first I'm going to discuss about Hadoop distributed file system. Later I'll just go with processing components like map, reduce, execution model. Hadoop follows this map, reduce, execution. What are the basics to the advanced level? And scoop is for importing data from other sources to Hadoop and exporting data from Hadoop to other. SQOOP, SQL plus Hadoop. The first two characters from SQL and the last three characters of Hadoop. Nothing but scoop. First two characters from SQL it has taken, last three characters from Hadoop, like scoop. SQL plus Hadoop, import and exporting from our relational databases to Hadoop, and from Hadoop to databases. Okay, from HDFS to databases. With multiple examples, multiple things, I'm just going to show you. Yet another resource negotiator. In the previous beginning versions of Hadoop, there were some drawbacks. All those drawbacks are rectified in the latest Hadoop version. That's why we call it as yet another resource negotiator, YAN. And pig is a very Apache pig, we say. Pig is also meant for processing the data. It can, why the name pig is given, nothing but it can process any kind of data, just like a normal pig. It can take any data and can process the data, right? In the same way, any varieties of data like structured, unstructured, semi-structured of data can be processed using pig. We use pig Latin. So pig Latin, it's a scripting language. It looks very simple and easier. I was just saying like 100 lines of Java code you can just write within 6 lines in pig. That is what the easiness of pig I was saying. And relational operators in pig, and in-depth knowledge on pig eval functions, diagnostic operation pick, Hive. Hive is a very important component among all this. So where it's a kind of data warehouse kind of environment. See this all these data warehouse kind of projects, all these projects are getting migrated towards Hadoop environment. Previously, like all the ETL kinds of projects, data warehouse kinds of projects, everything got migrated towards Hadoop environment. Where Hive we are going to see a kind of data warehouse kind of environment where we are going to create a tables and we are going to perform some querying on that data. So it is also a kind of processing component. NoSQL. I'm going to give knowledge on NoSQL database like HBase. HBase is especially designed for this. And also apart from this, I'll give knowledge on the streaming data and technologies. And before I go with Spark, first I'm going to discuss about Scala language, Scala variables, Scala collections here. Scala programming, Scala basics, data types, variables defining, Scala expressions, so Scala control structures, collections, transformations, all this. Later I'll come back to that after discussing Scala. Spark core, introduction to Spark and its data objects like RTD computation, its persistence options, Spark, how the computation happens internally, how it is data is getting processed, and various operations like groupings, aggregations, various actions and transformations within the Spark. What are the various built-in libraries we have got? Later coming to the Spark SQL. Spark SQL like streaming, case classes, data frame APIs, datasets APIs, RTDs versus data frames, working with different types of data like CSV, JSON, and also different file formats. And also I'm going to give knowledge on Spark streaming also, like creating micro batches using Spark streaming, and deployments, how the deployments like local and cluster, Spark applications, stages and tasks, driver and executor, Spark submitting, how to submit a Spark job, and how to, and just I'm going to show you like how to run this, how to just submit this Spark using different IDs like Eclipse ID, IntelliJ ID, and using build tools like Maven build tool and simple build tool like SBT build tool, right? And also I give knowledge on Cassandra, one more NoSQL database, Spark and Cassandra. Okay, that is what in depth I'm going to discuss all this nearly like I was saying like I won't take like 2.5 months, like 80 to 100 hours I'll be taking with multiple scenarios and tasks. Okay, fine. So if you have got any queries, then tomorrow just I'll be going with that. I'll be starting with how exactly data store and how exactly data processing within Hadoop. Okay. Tomorrow also you can attend the session, everyone. Same time, same link. Okay. So I'll just show how exactly data storage, how exactly data processing, and after that, just I'll be starting with after I'm going with the introduction of Hadoop, the other things, I'll be going with the first thing, first component, Hadoop distributed file system. Hadoop distributed file system, HDFS. And also before I go with the practical part, I'll be just demonstrating about the software. So everyone, first, if you are ready with the software, then only I go with the practicals so that you can practice the things. Is this course helps to get job for 3 years? So I'm going to give a 4+ years experience guy. How much experience is going to gain? That much of experience I'm going to provide you for that in-depth knowledge. So you can go for interview. You can just crack that interview. Okay. So can the timings be changed to 7 p.m.? Yeah. Some of them were asking for the change of timings, but okay. But just like 4-5 days or 1 week of time, you can just attend. Definitely, we'll make a change for that 7 p.m. right? Okay. But as of now, as we have announced that at 6 p.m. right? So at least for 1 week, we'll be running. This week, we'll be going with 6 p.m. right? So you just make your availability for this 1 week of time. Later, we'll just check. We'll change it. Okay? Fine. Yeah. Yes, Pooja Agarwal. Yes, go ahead with your queries. Yes, sir. Pooja Agarwal. Yes, just to go with your queries. Yeah, Sujit Nair. Yes, sir. We need to. Does we need to be in pro in Scala or up to some external it is? See, just is Sujit. It's just a Scala as a language, but we need to be much perfect on this. Spark executions, how the Spark has got Spark APIs. But just Scala is a language implementation will be same just for defining that values, variables, functions like. But mostly you need to concentrate on Spark APIs, Spark Core APIs, Spark SQL APIs, Spark streaming kinds of APIs. Your questions mostly will be on Spark side. Okay. Scala is not a big thing. Scala is much more simpler than Java. It looks very simple and easy to understand. Sir, I am new in big data and just I want to make my yes, Pooja, you can just make career in big data. See, the thing is, what are the job opportunities? Job opportunity reasons to choose this data, this big data means see that better career will be there, high job opportunities will there, high salary, big companies will hire, and you can see this big data everywhere, wherever you see this big data. This
Yeah, sir. Hello, sir. I'm
yes,
Pooja.
yes, go ahead.
Yeah, actually, sir, big data is unlimited data.
Yes,
Sir, I just want to take some suggestions from you.
yeah,
Actually, sir, I have just done MySQL certification course from
okay,
somewhere else. So, and I want to make my career in big data. But I don't understand that in which tool I have to go. I just want to go in MySQL using big data. So that's
yes.
why I ask you.
See,
Yeah.
one thing, Hadoop doesn't you okay, but one thing internally from where you are going to get data into Hadoop environment, from databases, from different OLTPs, from you are going to pull the data from the databases. So from the databases you are going to pull the data and you are just going bringing into Hadoop environment. Later using Hadoop we are going to process the data, right? So even this knowledge of this databases, okay, even if anyone doesn't have the knowledge, I'll be just we'll be discussing many example scenarios to us. By the end of that this course you'll also be perfect with those. So even this database knowledge also required, right? As I said already, you got knowledge on this databases. Fine. So for importing data and exporting data from database, I need to bring data and I need to export data to the databases. Okay. And if you think this, if you think that the one of the important component in Hadoop that I was saying, like Hive. Hive is one of the important component. So where we see HQL language, HQL. So difference, what is the difference between HQL and SQL? See, HQL is almost similar to SQL. Already you said you have got knowledge in SQL, right? So HQL, Hive query language, similar to structured query language. Here in this Hive, we are just going to perform some kind of querying there. So what all that SQL operations, whatever you can do, all those you can do in HQL also. Already you got certified with SQL, right? The same queries can be used in HQL also. Hive also supports that. Means Hive is going to make the unstructured data in the structured format, create a tables. On that tables you can perform querying. Any valid SQL queries you can apply on this.
Hello, sir.
Yes.
Myself, Kumari, sir.
Yeah, yeah. Go ahead.
My voice is audible.
Yeah, it's audible.
What is the difference between big data and Hadoop, sir?
Okay. So for example, yes, big data. What is the big data in Hadoop? So I'll just say today, day by day, data is increasing enormously. If I observe this in a simple way, if I can make you understand, if I take day by day, data is increasing enormously. If I take a big data as a problem, I can take Hadoop as a solution for it. If I take big data as a huge data generation, big data, if I take it as a problem, I can take Hadoop as a solution. If I take big data as a concept, I can say Hadoop as the implementation for it. Okay, to solve
Okay.
all this, right? Okay.
Yeah. Thank you, sir.
Can you talk to me after the class? Okay.
Hello.
Yes, go ahead. Any other queries? Yes.
Yeah,
Hello.
actually, I have one query. So, like,
Yeah.
actually, in nowadays, like, I can see the openings with not related only with respect to big data Hadoop, but they are asking more on the big data on cloud, like AWS, GCP, or Azure, or something like that. So, are we going to cover that part, big data on the cloud as well, or?
So one thing, if the requirement are Hadoop and Spark, see in the job description, you will be given a lot of technologies known. Fine.
Mhm.
Majorly, they will be specifically looking for Hadoop, Spark. Maybe today, if you see, if you guess, you can just Google and check Spark. More jobs are available on Spark. Previously, Hadoop, but even you need to have the knowledge on Hadoop and Spark jobs. Many jobs are available. So internally, you need to know how this generation, like what using Spark APIs, Spark Core APIs, SQL. So that is different. Okay, once you are taking into the cloud, but how this APIs can be used, Spark Core APIs, the data objects, how the see mainly in-memory computation is going to happen in Spark. Means data getting stored within the RAM level, data getting processed within the RAM level, how they are getting computed, what APIs to be used, and also for querying we have got Spark SQL, data frames concepts are there. These things are required more for that. So even in the interviews, they'll be mostly concentrating on the Spark Core APIs and this data frames, data sets, streamings, and this how to bring the data and how to export, import those things. Forget about the
Different.
environment. Forget about those environments. So even for it's a Hadoop and Spark development and for administration side, okay, it's a separate thing, separate wing. So we no
Okay.
need to worry about these things.
Okay.
Hello.
Okay.
Yes.
Yeah. Hi. Good evening. Actually, I'm working as an data warehouse developer. So, will it be a good choice to go for Hadoop?
You are working in which one which technology now currently?
Currently, I'm working as an ETL developer.
Informatica.
SSIS.
Okay, so previously, like it's today, if you see a lot of, I was saying like all that ETL kinds of things. Today, if you see what all the projects we see in Hadoop, therefore see the data warehouse or ETL kinds of things, where we are going to pull the data and we are just going to bring into Hadoop HDFS. Later, we are using like processing components like Hive or Pig or MapReduce or Spark, applying this logic and just processing it, and later just we are just going to visualize and generating reports like. So here
Okay.
also in Hadoop, we are going to process those things. So Hadoop is mostly Hadoop Spark, especially Spark is mostly used in the industry currently. You can just check it. Even everyone can just Google and check the jobs in Hadoop and Spark, and mostly. And even if as you got knowledge on that data warehouse, like even that it's much better for you to understand the things.
Okay. So, we can say that having a knowledge and data warehouse would be an advantage while learning Hadoop.
Data where yes, compulsory yes, because uh, you'll be in touch with the this what is that mainly like SQL concepts,
Okay.
this database concepts, right? Mostly,
Hmm.
but there that is different. But here it is totally different. Here in Hadoop, totally we have got our components, fine.
Okay.
But mostly as you got a command on, so it's a much. It will be very little bit easier for you to understand these concepts. Fine.
Okay. Will you also provide a printed notes for these concepts?
So I'll be giving the soft copy of the notes. I'll be
Soft
providing
copy of
all
the
the
notes.
soft copy of the notes. Lot
Okay.
of notes I'll be providing for this.
Okay.
Hi, Sagar this side. I have total 6 years of experience in Java as a Java developer. So, have you provided any projects? So, I will convey to interviewers. So, I have lost 2 years experience in Spark and Hadoop. So,
Yeah,
then
I'll just help you to build that resumes, everything at the end of that course. I'll be just giving you that responsibilities, roles, everything within this Hadoop as a Hadoop developer and Spark developer. I'll just be guiding you all those things. I'll
and
take some.
any certification available for the Spark or Hadoop. So, official certification is there. So, we will shortlisted resume.
Yeah. So certifications also available. Yes, I'll also take that sessions on that, how to approach for that and what are the contents you need to concentrate more on those. Everything I'll be discussing as part of our course.
Okay.
Okay, fine. So
So, excuse me, sir.
yeah, yes, go ahead.
So what will be your timing? Six to seven
As of
timings?
now, we are going with 6 to 7. So later again, I'll discuss with every one of you if there is any change. Okay, if everyone are okay with those timing, just half an hour or 1 hour, just moving backward. Okay, fine. If it is
Hello, sir. I have a doubt.
yes,
Sir, the PySpark also is included in the syllabus, it will be separate session.
see one thing. I deal with Spark with Scala and Spark with Python both. PySpark,
Okay.
but PySpark is not part of this. So Spark, everything will remain same. Only that instead of Scala language, we will be using Python language there. So even
Okay.
Scala is preferred more, but
Mm.
even Python also can be used. I'm saying both are languages, Scala and Python. Fine. We
Yeah,
will be
yeah.
discussing Scala.
Okay. Okay.
Fine. Okay. So fine. So if I'm done with the queries, then I'll just sign off for today. Meet you tomorrow at 6 p.m. sharp. And you can just tomorrow also we'll discuss on this Hadoop and all this other part of this. Okay, fine. We'll meet tomorrow same time with the same link. Thank you all.
Thank you.
Thank you.